With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, question says that let f of x is mod of mod x minus 1, g of x is mod of x plus mod of x minus 2, h of x is maximum value of 1 x cube if a, b and c are the number of points where f of x, g of x and h of x are not differentiable. Then we have to find the value of a plus b plus c. So we have given functions f of x mod of mod x plus 1. So let us consider this function first. Now this function has mod of x and we know that mod of x is defined as x and minus x. It is x when x is strictly is greater than equals to 0 and minus x when it is less than 0. So we can say that mod of mod x plus 1 will be x plus 1. This will open up to give x when x is strictly is greater than equals to 0 and will be minus x plus 1 when x is strictly less than 0. Now this is in modulus also. We have just opened this case. Now let us solve for this modulus also. So we can see that for each case, that is for x greater than equals to 0, we will have two cases for mod x plus 1 and similarly for x less than 0, we will have two cases for mod x minus 1. So let us take the case 1, that is when x is greater than equals to 0. So for x greater than equals to 0, the modulus of modulus x plus 1 is given as x plus 1 modulus and this will be defined as x plus 1 when x is greater than equals to minus 1 and it will be x minus, this will be minus of x plus 1 when x is less than minus 1. So this will be the case. Now we know we have to consider the other case also. So this is case 2 when x is less than 0. So for x less than 0, it is mod of minus x plus 1 and this will be minus x plus 1 itself when x is, this is when x is greater than equals to 1 and this will be minus of minus x plus 1 when x is less than 1. This will be the two cases. This is minus 1 everywhere. The function that we have given here is minus 1. So let us replace everywhere. This is minus 1. Now let us look at the function, modulus function that we have got. Since we are considering the case x greater than equals to 0. So the case x greater than equals to 0 out of the two cases will be followed by x greater than equals to minus 1, because if this is the number line and x is equals to 0 here, minus 1 is here and 1 is here. So if we are considering x greater than equals to 0, that is we are considering these values, and x greater than minus 1 will also correspond to these values, but x less than minus 1 will correspond to these values. So we can say that for x greater than equals to 0, we are taking this case. So we have, if we define mod of mod x minus 1 function overall, so this will be the function x minus 1. It will take the value x minus 1 when x is, this is when x is greater than equals to minus 1. So for these values, this function is taking value x minus 1, and for the values for x less than 0, So x less than 0 will correspond to x less than 1. So this region, if x is less than 0, x is less than 1, so this value of function will determine here. And this function can be also written as by multiplying with minus, this will be x plus 1. So we can say that this function f of x is x plus 1 when we are considering x less than 1. Now if we look at the real number line for these values, x is greater than equals to minus 1. That is, we have covered this value. Also, x is less than 1. We have covered this value also. So this region, that is the region from minus 1 to 1, is twice in this domain. So we can say that from the interval minus 1 to 0 and from the interval 0 to 1. This is from minus 1 open and from 0 to 1. This function will have a sharp point at minus 1, 0 and 1. This function will have a sharp point at minus 1, 0 and 1. So we can say that at the sharp points, this f of x function is non-differentiable. So f of x function is non-differentiable at x is equals to minus 1, 0 and plus 1. So that means there are 3 points of non-differentiability. So we have a is equals to 3 because a that we have given, it was given as the number of points where fx is not differentiable. So fx is not differentiable at 3 points. Now let us consider the function g of x. It is mod x plus mod x minus 2. So g of x function mod x plus mod x minus 2 we have. Now, so we know that mod x is not differentiable. If we consider mod x, it is not differentiable at the point x is equals to 0 because at x is equals to 0, this makes a steep sharp point. Similarly, mod x minus 2 is not differentiable at x is equals to, this is mod x minus 2. So we can say that g of x function has 2 points where g of x is not differentiable, where it is getting a sharp point. So we can say that g has 2 points of non-differentiability. And if it is having 2 points of non-differentiability, that is, we have the value of b as 2 because b was defined as the number of points where gx is non-differentiable. Now look at to the function h of x, that is maximum of 1x and x cubed. So h of x is defined as the maximum value of 1x and x square function. Now we know that for different intervals in domain, if we consider the domain as R, then in different intervals x will be maximum and x square will be maximum. So this will divide in some cases, but we have to find the points of non-differentiability. So it doesn't matter which is the maximum value out of the 3. The thing is that the function, this is constant function, this is a polynomial function in degree 1 and this is also a polynomial function in degree 2. And we know constant functions and polynomial functions are always continuous and always differentiable. So whatever be the maximum value out of the 3 functions, we will have non-differentiability points. Number of non-differentiability points as 0, whether for 1 or for x or for x square, it will be 0. So we have got c is equals to 0. So now we have to find out sum of a, that is 3, b 2 and C0. So this will be 3 plus 2 plus 0 and this will be 5. So 5 is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.